So we started class with these as a warm-up, so I'll just put these on the video just so that you can check your work. If you are doing these, I'd recommend trying these next three on your own, and then if you want to check your work, just push pause, because I'm not going to be on this for that long. So here's the first one. Here's the second one. I did some color coding at the beginning so that you could see how I rearranged the equations so that they would fit nicely into the augmented matrix. Well, after they're set up, I guess I could have kept the top one blue and the second one green. And the last one required color coding for a little bit longer. So since it had fractions, I multiplied by a number that would get rid of the fractions. The smallest number I could think of, in this case, was 18. So there's the blue equation, getting it down to just x's, y's, and a number. And there's the green equation. So you can see that when you multiply this, 12 and 3 would cancel, leaving you with a 4, but that 4 would still multiply all of that. So that's where those numbers come from. And then once you have your two equations, you have a setup. And you'll start to notice when the numbers don't appear nice, like the 15 and the 8 at the front, that's not very nice. You can just take those numbers and subtract each other, getting your value of 0 in the bottom left-hand corner. Again, I like to write out what I did so I know which row I'm changing, which row I'm keeping the same. I know that some of you don't like writing some steps down. I think this one where you divided by 241, it was so obvious what you did that you probably wouldn't screw it up. So if you didn't show that work there, I could understand. But for the most part, it is helpful to write down which row you're changing and what you're doing to it to remind yourself which one stays the same and which one you're changing. And there's a fair bit of mental math, so these are easy to have mistakes happen. So today, we extend it to the 3 by 3. So we set up our augmented matrix. Again, we have to make sure that everything is in order, x, y, z. So 4, 1, 1, draw the line, and a 5. 2, -1, 2, and a 10. And then 1, -2, -1, and a 2. And our goal will end up looking like this. We'll have 1s along the diagonal, 0s everywhere else. Now, just getting a 0 somewhere, like for example, I can get a 0 quite easily in the top right-hand corner by adding the bottom one and the top one together. So that may seem like a good idea. However, if we don't do this systematically, okay. So if you get the 0s that you want, but you don't get them necessarily in the right order, you sometimes find that the next time when you try to get rid of another 0, one of your 0s goes away, and you're like, oh, it's no longer a 0. So there is a systematic way to go about this. And it's sort of similar to a systematic way that you solved a 3 by 3 system of equations like this in the past. In the past, the first thing you would have done is chosen one of the variables to get rid of first. Maybe get rid of all your x's, all of your y's, all of your z's. We're going to do the same thing here. I'm going to circle these two 0s, and I'm making a note that that is our plan to get rid of that first. Once you get rid of those ones, you will be able to get rid of that number and make it a 0 second without causing much problems. And once the bottom corner are all zeros, you will be able to make these ones zeros next, and finally make this one a 0. Now we have our equations set up. I wrote them just the way that they appeared. If you don't like the order, or if you like to have, like sometimes students like to have the 1 already in the top right-hand corner. If you like that, what you could do is you could write them out in any order to begin with, or if you notice something after you've had it started, if you want to, like I can exchange row 3 and row 1. What would that do? Okay. Row 3 was 1, -2, -1, 2. And row 1 was 4, 1, 1, 5. Row 2 stayed the same. Okay. Sometimes people like to do that. Not necessary, but also if you like to start with a 1 in the top left-hand corner, you can look through your equations at the beginning and write them out in any order you want. So your first matrix that you write down, you could write them out in whatever order you want. Now, I want to first get these zeros. So I'm going to take row 2, and I'm going to change row 2 to be row 2 minus 2 row 1s. At the same time, I'm also going to change my row 3. And you can do this in one system. I'm going to take row 3 and take row 3 and minus 4 row 1s. So I'm not changing row 1, 1, -2, -1, and 2. Row 2, if you take row 2 and subtract 2 row 1s, that will get us our 0 there. Row 2 minus 2 row 1s, positive 3. Row 2 minus 2 row 1s, positive 4. And row 2 minus 2 row 1s, 6. Row 3 is getting changed. You're taking row 3 and minusing 4 row 1s. So that will also get us our 0 here. Row 3 minus 4 row 1s will give us positive 5 there. -7 there. No. Just a second. It wasn't positive 5. Okay, I got to thinking, ooh, I was already thinking about the mental math I would do next, and I started subtracting row 3 minus 4 row 2s. Very easy to do, but disastrous results. So I got to go back. You got to be, you cannot try to do too much at once. It's not hard math, because all I need to do is row 3, which is 1, minus 4 row 1s, which will be plus 8. This should be a 9. And 1 minus 4 times minus 1 is 1 plus 4. This will be a 5. And then 5 minus 8, -3. And you can see if we color code things, we successfully got those two zeros first. Now to get a 0 in the the second 0 that we want, which is where the 9 is. You could get that to be a 0 using row 1 or row 2. However, if you use row 1, this 0 in the bottom left will go away because row 1 has a value in that column. So in order to get the 0 that we want next, we have to use the two equations with the 0 already there. So I'm going to go to row 3. I want to get rid of the 9. I use the equations that I have. So row 3 is going to be row 3 minus 3 row 2's. Again, I cannot use row 1 because then I'll get rid of those zeros in the green column. Does that make sense? So now, row 1 doesn't change. 1, -2, -1, 2. Row 2 is not going to change. 0, 3, 4, and 6. But row 3 minus 3 row 2's, see how nicely that still stays 0. 0 minus 0 is still 0. But 9 minus 9 will now be 0 here. And 5 minus 12 will be -7. Then -3 minus 18 will be -21. Okay? So now we successfully got that 0 second. We can now get row 3 to be a 1, so row 3 divided by -7, 1, -2, -1, 2, 0, 3, 4, 6, 0, 0, 1, and 3. Perfect. Next, we want to get the zeros in the third column. So we can do that by using row 3. Row 3 is going to be important to use because we want to keep, well, for one, that 1 is really easy to use. So for example, I can change row 1. I can do row 1 plus row 3. And I can change row 2 to be row 2 minus 4 row 3's. So the row that's not changing is row 3, 0, 0, 1, 3. Row 1, I'm just adding row 1 and row 3. And because of the zeros, this is helpful. Those ones are going to stay the same. This one will become 0. And 2 plus 3 will be 5. And row 2 is row 2 minus 4 row 3's, so this will still be 0. 3 minus 0, this will still be 3. And 4 minus 4 will be 0. And 6 minus 12, -6. And now I got a 1 in row 2. And we have successfully, as far as color coding things, what did I use up top? Purple. We successfully got these ones to be zeros, third. And now we need to get the last 0. There's only one way to do that. So row 2 and row 3 won't change. Row 1 plus 2 row 2's, well, this will stay a 1. This will become a 0. This will stay a 0. And row 1, which is 5, plus 2 row 2's will be 1. And we successfully made this a 0/4. And because we started with the 1 in the top left-hand corner, we don't have to divide 1 extra time to get all 1s, 1, 1 along the diagonal. Now, if we want to check 1, -2, 3, we can go back to our original equations. 4 minus 2, 2 plus 3, 5. Yes. Second one, 2 plus 2 is 4, plus 6 is 10. And the third one, 1 plus 4 would be 5, minus 3 would be 2. Plus C. Yes. I'll scroll down. So we've got our solution. Okay, ready for one for you guys to try? Of course not. Here, I will put up, as you're working on this one, I'll put up the solution for this one. Next quiz. And then test next Friday. Okay. Oh, that's exciting.